one summer work in a plant and have that kind of touch base with people.
That's always a great background to be able to have some of that real world experience in addition to the kind of management types of experiences too.
Yeah, absolutely.
Are you involved in any other organizations, things that promote kind of learning in the field of automation, working with student programs, things like that, that help foster the next generation of people coming up into this industry?
Yeah, for sure. So Rockwell as a whole, the company where I work, we have a really strong relationship with First Robotics. So that's something that I haven't personally gotten super involved in, but Rockwell is very involved. And so a lot of times when I meet students at career fairs and I'll say, do you know what we do at Rockwell Automation? They'll be like, yes, I do, because I was in First and I know all about your products. So that's always something really exciting that I like to plug for anyone who's got young kids. My kids aren't quite ready to be in First yet, but when they are, I will definitely make sure they get involved. But personally, I do a lot of work with our corporate Society for Women Engineers affiliate at Rockwell, and I've supported multiple global SWE conferences. I've led our participation from Rockwell, and I find that to be a really great way, just again, to interact with those young people coming out of college looking for roles in the industry and just hearing their experience and sort of giving them a view into what's possible within engineering. And so yeah, that's probably the one that I'm most passionate about, spend most of my time with.
I always appreciate it when big companies work with schools and organizations to be able to provide that real world equipment experience and learning experience in the classroom. It's just, there's no match for having that hands-on experience when graduating from college.
Yeah, absolutely. Somebody was like watching their nephew at a first competition and they saw my company's logo and texted me. They're like, "Hey, isn't this what you guys do?" I was like, "We do, in fact, provide equipment to First Robotics teams." So yeah, absolutely.
Could we take just a couple of minutes and discuss just a little bit about some of the most recent advances in sensing technology? I know that there's thousands of different kinds of sensors and tons of different advancements that are happening in sensing all the time. But if you could just kind of provide us some of the most up-to-date advancements that have been happening in the last year, just to kind of give our audience a little bit of context into some of those things that are happening in the industry today.
Yeah, for sure. When it comes to sensors, I would say for factory automation in particular, adding communications to the simplest devices has really been probably the major advance that I see impacting our industry within the last 5 to 10 years. So when I joined Rockwell, we were in the process of putting all of our sensors, or as many sensors as possible, on IO-Link, and that journey continues today. So IO-Link is a serial protocol. It's not a field bus, so it works with any field bus, and it is an open protocol, and that has been a huge step forward in terms of being able to communicate with devices that previously were really just on off and did not provide a lot of information. They had to, come back into an IO and then, go from there in terms of applying logic. So adding IO-Link to sensors or just other communications in general has been, I would say, the number one. And then additionally on that same, I guess, theme of communications, another one I'm starting to see a lot of is embedding things like NFC or other wireless communication protocols within devices so that you can, for example, configure the sensor directly from a mobile phone that's close to the device. So that's something that I think we'll definitely see a lot more of. And then the other big one that I'm sort of seeing in my field of work is around vision sensing and really the commoditization of vision sensing. So vision systems still tend to be, limited to fairly expensive and challenging to integrate systems from kind of a few vendors, but just having a camera of some kind that can sense and provide a little bit more information back to the control system as opposed to just a standard on-off photoelectric or something. That is super common and becoming much more reasonably priced. So I think there's a lot that just opens up when that happens, when you're not, deploying a $40,000 vision system to do inspection or quality control. You can have, a few $100, $1,000 camera and do some similar processing and bring it into an IPC or to the cloud and do some AI manipulation of that, because the hardware itself is just so much cheaper. So I think that's probably one of the other big ones that I would say is kind of an interesting disruptive trend in the industry.
Well, kind of taking a step back there to your first point with the IO link being embedded in all the sensors or many sensors these
Yeah.
days. I know that from my limited experience with IO link and visiting trade shows and walking around, everybody's got IO link sensors being compatible. Heard as a benefit there is being able to not only receive the process information like the discrete signals or analog signals, but also being able to receive information about the sensor itself. And that can help collect some data, which we'll talk about a little bit more later, like with condition monitoring, being able to monitor the health of the sensing devices themselves.
And I think with that, yeah, you can really consider that the sensor, it's really dual purpose, right? It's providing the actual feedback for the control loop around, hey, do I need to like divert this package on the conveyor, or do I need to change something else in the system? Do I need to actuate something, or is the sensor overheating? Is it still communicating? So it's providing those two different channels of information at the same time. And one thing that I think is fairly consistent across the industry, we definitely do at Rockwell, and again, I think this is a consistent take across the industry, is to not even upcharge for IO-Link. So it's basically standard. You can choose to use the device as IO-Link, or you could choose to wire it for a 20 milliamp, and it's the same product. And so there's no real upcharge. Again, you're changing out the IO for an IO-Link master, but it's something that's essentially smart is standard now, and you're getting the control and you're getting that analytics on top of it.
And that's awesome to see, and a huge benefit, I'm sure, for the end customers to not have to worry about whether that data is going to be accessible to them in the future, because they have to have a larger budget just to be able to afford to make their process more efficient. That's got to be a real relief for them.
Yeah, and you can stock the same, like some OEMs might make different machines, so they might have like a more standard level machine that doesn't deploy any analytics or advanced sensing. And so they could just wire the product standard, and they would source the same product, have the same product in their storeroom to then deploy on a more advanced machine that does include IO-Link and analytics. Yeah. So
looking at those two different reasons for having data, there's the analytics side, but then also the process control side. That kind of implies two different urgencies of how to use the data. Some of them you need to make decisions immediately to divert that package, or something you can't wait a minute to be able to get analytics. But with the analytics side, you store data for a longer period of time. It's not quite as urgent. Does this usually mean that there's two different networks going on, or is all of this data traveling over the same field bus network down at the field level? I don't think it necessarily has to be two different networks. I do think that it is for sure two different speeds. So absolutely, if something's within the control loop, it needs to be very, very quick, millisecond or sub-millisecond update rate. And so for sure, that's going to be something that you're going to, and you're going to be sending that back to the controller. But if something is simply analytic data, there is the high likelihood that you really don't even want it in the control loop. You don't want that analytic data bogging down everything else that you're doing on the network. I will say, cloud is a very talked about term in this respect. And there's, certain protocols that you could communicate directly to cloud with. But a lot of customers that I've spoken to don't even necessarily want their data going to the cloud, even for analytics. They may not have access outside, they might be completely firewalled, or they just prefer to keep that analytics on-prem. So there's still likely some other compute surface, not the PLC, where they're doing this analytics. But I don't think it necessarily implies a different network, just you may be routing the data separately. But I do think there are times when, for sure, customers would prefer to just directly have that analytic data go wherever it needs to go at the edge of the cloud. Yeah. Whether that's information that's stored on-prem or in the cloud, I hear so much about AI power for either analyzing or analyzing vision systems, like you mentioned a little while ago. Do you
Yeah.
think that that really, there's a lot of hype around it, but do you think that's impacting things over the last couple of years, that seems to just kind of have exploded? Everything is AI driven. Is that really impacting things as much as they say, that ability to take in more data and process it faster and more efficiently?
So it's definitely very buzzy. I do think it can be very powerful if you know how to use it right. And, sensor data, for sure, there's machine learning methods that can identify abnormalities, can improve throughput. Yeah, like you talked about vision. We have a product of Vision AI. It looks at I, images of products and can tell, quality control checks, is the label on properly, something like that. That's all technically AI. But I think with sensor data in particular, and a lot of times sensors can be embedded in other devices, right? Like you might have temperature sensors on every single device in your facility. Vibration sensors can be embedded in other devices, et cetera. So you might just get this mountain of data. And if you don't have good metadata to explain what that sensor data is and what it's telling you, the AI could be somewhat meaningless, right? So, particularly when you're talking about factory automation, it's important to know which line, which machine, which shift, which pieces of information are related to one another, if you really want to be able to provide actionable info. So I think that's one of the ones that I think people struggle with. They might get a mountain of data and not have it classified very well in terms of the metadata. And then, AI will take anything, right, and spit anything back at you. And it's sort of on the user to make sure that that information is categorized appropriately. And, different vendors have different ways of doing that. We try to do something where we have standardized data models across our devices. So, for example, one piece of information that we provide with a lot of our devices is the remaining useful life left. So, and that's specific to each device. And that's stored in the same place on every device. And then additionally, we store the device's physical and logical location in the same place on each device. So you could either write your own standard templates on an HMI or in software in a browser, or we provide them sometimes. If you just want to be able to see across your machine or different lines with different machines, what particular devices are going to need to be serviced more quickly than others, you could easily snapshot that without having to write a lot of code. So that's something we're trying to do. But I think, all different vendors have their own ways of handling that to try to make things easier for customers so they don't just have this mountain of data.
Well, that mountain of data, to me, having, again, a limited amount of experience working with AI-based systems, it seems like that would probably be the most intimidating thing, is not necessarily the retrieving of the data, but just knowing what data needs to be gathered, or of the thousands of data points, I could collect all of it, but it just seems like a very difficult mental challenge to just figure out what to do. So being able to make things user friendly while at the same time one of these elements is getting more complex, taking something else and making it less complex has got to be another real relief for customers that may not be data science professionals.
Yeah, exactly. I mean, and then there's definitely, like, we have customers who actually do have data scientists that work for them that are on staff, and that's all they do. And so those customers say, like, I just want the data. I don't want you to do anything to it. So there's kind of, everybody's on their own place on their digital journey. I would say more people are on sort of the earlier side that you just talked about, right? So like they need that simplification to actually make use of the data and make use of something like AI. But there certainly are some, very advanced customers who truly have data scientists on staff, and they do their own data mining. They have their own cloud, they have their own system, and all they want to do is just attach to the data and suck it out of the devices and figure out what to do with it. So we try to provide something that can work for everyone, wherever they are in that digital journey.
I've heard a lot of people talking about a trend that's ongoing and possibly will continue into the future, where a lot of the graduates that are coming to work in the industrial automation field are more familiar with computers and coding, fewer of them familiar with hardware, electrical systems, and more the physical control systems. Do you find that already beginning to influence the way companies are thinking about it, or is it still kind of dominated mostly by people that are more of the background in hardware and electrical systems? Where are we kind of at in the industry with that change right now?
I mean, we're definitely getting more requests about the latter. I think there's two things that are driving it. One, we talk about operators as opposed to like controls engineers or commissioning, but like actual operators, like there's a challenge there too, in the sense that we have people who've been on the job 30, 40 years who just like know the machines and they know, hey, when that machine starts sounding a certain way, there's a problem, something's off balance. I'm going to, shut it down and fix it before we have a catastrophic failure. And so that's, when we talk about condition monitoring, can we be the eyes and ears of the machine, when this person hopefully retires and has a nice happy retirement on a beach somewhere, and you have your new person coming in who doesn't really know that, can our sensors be that eyes and ears of that individual? So we definitely have that piece of it. The other piece around just sort of being more familiar with like traditional, like a Python scripting language as opposed to like ladder logic, absolutely. Like that is a question that we for sure get, and we are trying to incorporate into our control system going forward, that new engineers coming out of college who they just feel comfortable in those scripting languages are able to use that in conjunction with more traditional PLC logic.
I think that's probably the most significant trend I've noticed just walking around the trade shows and hearing all the updates is the software side of automation taking major leaps and bounds. But I guess that's no surprise because computers, they keep getting smaller and faster, and really that just impacts our ability to make more capable software for the same kind of machines. Now for the next little bit, I want to talk about more of a specific emphasis on safety in sensing, because earlier we were talking about urgency of data, needing some data for your process a little bit faster, or some for analytics, you don't need it quite as fast, but for safety, it needs to be like top priority urgency. Right before we start talking about some of the things like how does it work with condition monitoring, I'm just curious, how is sensing, just generic process sensing, different from safety sensing, both in kind of the hardware, the protocols that the safety signals travel on? What really sets safety apart from the rest of sensing?
Safety sensors, whether it's an e-stop, laser scanner, non-contact sensor, switches, safety mats, they meet specific standards set by governing bodies. So typically IEC 61508 or ISO 13849. And so when we design to those standards, we're typically trying to meet some guidelines around the probability of a dangerous failure, right? So you achieve a certain performance level or claim level based on how low the probability it is that the device or the protocol will encounter a dangerous failure. And so compared to a typical sensor in the hardware perspective, so we're likely going to have forms of both redundancy and diversity in terms of the electrical and the mechanical design, and the firmware as well. So the firmware will have diagnostic coverage, it's called, right, where it's checking that, you'll have two different micros running the application code, and they're cross-checking with each other to making sure they're getting the same answer. Here at Rockwell, we utilize SIP Safety as a protocol that runs on top of Ethernet, again, with that certain level of priority, but also fidelity within the signal itself. And so again, the sensors might be very, very similar. I mean, a non-contact sensor is very similar to a standard proximity sensor with an actuator. But again, inside that design, you're going to have that redundancy, diversity. There's probably some extra hardware. That's often why they're more expensive, right? There's literally more inside the device that's making it safe, that's making it extremely, extremely unlikely, 10 to the negative ninth likely that you're going to encounter a dangerous failure in operation.
With the integration of IO-Link into a whole bunch of different kinds of sensors, is IO-Link by itself, can that carry safety signals, or are there variations of IO-Link that are capable of apart from IO-Link and kind of set on a different network? How does that usually look?
Yeah, that's a great question. There is a form of IO-Link called IO-Link Safety, and it is a protocol that is very similar to IO-Link that does allow you to send signals safely. It is like IO-Link, it is a point-to-point topology, but you can have, other vendors have a distributed IO master that'll have, traditional IO, IO-Link, and IO-Link Safety. So that form factor, I think, is gaining popularity, as well as actual devices on IO-Link Safety. We have at Rockwell something called GuardLink. That's a serial protocol that has a safety signal, and there's other versions of that from other vendors as well. They have other serial protocols with safety signatures, and I think those are also can be super helpful. In particular, with our GuardLink protocol, it is serial, and so in many cases, you are daisy chaining together a bunch of e-stops down a conveyor or non-contact sensors on doors on a packaging machine, as an example. So we feel like that's a very helpful safety protocol to have for our customers, because they're getting that probability of failure is very, very low, and they're able to claim a certain safety level based on the fact that we have this safety protocol with a unique signature that's being checked and can allow you to actually daisy chain more devices with the same safety level, as opposed to just hardwiring those devices. And I think, with IO-Link safety, with SIP safety over Ethernet, I think we'll only continue to see more opportunities for machine builders and customers to put their safety devices on some kind of protocol and communicate with them more directly, as well as get that analytical information.
So with a daisy chained kind of protocol, instead of just hardwiring them all together, does that enable things like previously, if a whole bunch of daisy chained e-stop buttons and one was pressed, you'd know that the safety circuit was tripped, but you couldn't identify exactly where or which
That's
device.
exactly
And
it.
now
Yeah.
you can, with protocols, can you
Yep.
more effectively figure out, like, oh, it was a problem exactly here with a timestamp of this time, and that could be a real enabler and time saver for diagnosing safety issues.
Yeah, that's exactly it on our GuardLink protocol. That's one of the things why customers like it, because talking about that packaging machine with a bunch of doors, they all have non-contact switches. If somebody left one slightly ajar, the machine won't start up. You can't tell just by looking at it, especially if you're 20 feet away, which door is slightly open. With this, it would tell you exactly it's like door number 3. And that way you can save yourself walking around trying to figure out exactly which one. Just walk on over, shut it, the machine starts up. Yeah, absolutely.
That leads me to another question then. In kind of looking at analytics, you can use analytics for condition monitoring for sure, able to monitor the health of a machine and or the health of the devices themselves and see when things need to be replaced. But in the case of safety sensors on a door, can you access those safety sensors just like you can standard sensor data to be able to perform analytics? Like, this one door seems to constantly be left open at this particular time or this particular shift. And so you can also use those same analytics to be able to make better decisions for future optimization of your process too. I'm assuming that safety sensors really can still
Yeah.
provide that same data ingest
Yep.
to be able to make decisions.
Yeah, exactly. So even if it's the sensor is primarily there for a safety function, you can still mine that sensor for data on how your production is running. So exactly what you just said. You could compare the frequency of an e-stop being pressed on one shift versus another to understand, is there some additional training we could be providing the operators? Is there something that's going on at that shift that's causing that to happen? Is the, to your point, like, is the machine designed properly? Like, maybe there shouldn't be an e-stop there. Maybe there should be some other method of keeping that safe. If someone's pressing an e-stop, there's something else probably that's going wrong, right? So for sure, that can help you analyze how the production's running, try to be more efficient. And then, yeah, exactly what you said about the condition monitoring, that is applicable on safety devices too, and can also help improve uptime. So we have light curtains, right, that might get dusty. And if they're getting dusty or occluded in some other way and they're not working properly, you're going to trigger the safety function on that, shut down your operation. If you have a warning that the margin is getting lower on that light curtain, you can go and just hit it with some compressed air, wipe it down before you get to that point, before it triggers and puts you into a safe state. And you're like, what? There's no reason. Oh, it's just the light curtain's dirty. The other one that we have a rope pull, a cable pull that monitors the tension. And so you could see over time, is it starting to sag? And you could avoid some unplanned downtime because of a nuisance trip, essentially. Yeah.
blending here the safety and the condition monitoring. I know that there's a huge push for distributed equipment so that you're getting some of the controls a little bit closer to the point of application. Maybe motor drives are a really good example of, instead of every control process or every analytic process happening at a central control system, are there any opportunities now to be able to perform some of the analytics right on a controller that's closer to a device? Maybe as an example, like a VFD, being able to monitor current, voltage, those things that are really already
Yeah.
monitored for the operation of the machine. Is there some way to be able to either directly take that data or even process that data directly on that controller to be able to monitor the condition of the motor and check, analyze its consumption over time, the typical analytics things? Can those be done right on the controller or routed directly from the controller to save a little bit of burden on the central control system?
Yeah, absolutely. I think it's always most efficient to put the analytics as close to the device or the sensor as is economical. So if you have a more complex sensor, I think it's more likely that you're going to have analytics built in just because you'd have the compute power necessary to do that, and it's going to be cost effective, right? I'm not going to put analytics on a proximity sensor. It's just not, there's not much to analyze, and it's also just going to make it too expensive, right? But I think, yeah, if you talk about a VFD and looking at something like motor current signature analysis, we do have some of our newer architecture class drives do exactly that, right? So they'll analyze that motor current signature to try and understand how the drive is operating. We can combine that with AI to look for potential failures actually on the load, but looking at the drive to see what could be going on. And I think additionally, there's those other opportunities where you might just have a sensor that's completely out of the control loop. There's, maybe it is a really cheap sensor that you don't plan to do analytics there, but then you want to directly send that information to the cloud to do the analytics. So some really lightweight communication protocols like MQTT, OPC UA. I think those are where people are really utilizing those and just pulling that data really, really quick, really lightweight to exactly where you need it to be to do that analysis. If it's a really simple, cheaper sensor that you're not going to be doing a lot of computing on the sensor itself.
It was probably embarrassingly recently that I really kind of understood the concept of edge, because you've heard of edge computing for years, but it wasn't until just recently that I realized really what edge means is that concept of taking things as close to the point of application, like
Yep.
you said, as reasonable and economical, not always right there, but the
Yep.
edge of the point of application versus the point of sending it further upstream for analysis and collection. It's a simple concept, but I think that provides a lot of ambiguity or misunderstanding to what this means. It's not a particular kind of device.
Yeah, the
It's
edge
more
is
of a
not one
concept of a
thing. Yeah,
location. Yeah.
exactly. Exactly. Yeah, for sure.
Especially this world of software and data there's a lot of layers of complexity, but manufacturers seem to be trying to give more flexibility to the customers. And while that's great, I think that when we see things like a long list of field bus protocols and, like you said, MQTT and OPC UA, it can sometimes be a little intimidating and confusing, while the end goal of it really is to provide flexibility for whatever the wherever the data needs to be going to accomplish its job.
I mean, that's always the balancing act, right? Like, if we gave customers every single thing they asked for in terms of different communication protocols and places to direct that data, it would be very, very complex. But I think what's important is providing as much as possible that ability for customers to bring the data to where it needs to be, right? So we might not have, like, we don't have OPC UA clients on any of our sensors today, but if customers have their own, we do have the ability, we have an OPC UA server that they can connect that data in, as an example, right? So just trying to, make it as simple as possible without offering that complete menu that gets to be a little bit overwhelming.
That would be very overwhelming, and probably different people with different experience would see that completely differently and be able to use it in totally different ways. which I guess kind of brings me to the next point of condition monitoring, condition sensing, which I kind of see in a company like of the size and scope that we've been talking about. There's really kind of two different categories of people that are going to use the data for particular reasons. And one of them would be kind of the engineering operations level, where they're more interested in the health of the equipment, making sure that the equipment is working properly. And then there's secondarily, or perhaps more importantly, there's the business case, which is all about keeping the business running, which looks completely at the financial aspect. And of course, while those two are tied together, would you say that there's one of those areas that tends this analytical data more than the other, whether it's for a business case or more of an engineering operations case? Or would you say it's kind of equal, but really with different but related intentions?
I think maybe today, at least from where I sit and the customers I talk to right now, it's more about benefiting engineering and ops, but I think increasingly it will be on that business side. And again, I think it's just because we talk about that digital journey and where customers are. So many customers are like still doing preventative, predictive maintenance just on a whiteboard, right? Like once a month, I walk around and I make sure nothing has fallen off this machine. Like that was an actual example a customer told me one time. So they're super early in that journey. So simple data, simple insights are really useful to them. And so we talked about enunciation of safety devices, like that's a huge one. Heartbeat of a sensor is another one that is just, if the sensor gets knocked off with a forklift, if you're not checking for that heartbeat, if it's just hardwired, you won't notice that the sensor's gone until you start to see packages piling up or whatever's happening on the conveyor. If you have a heartbeat that you're monitoring, it's going to start flashing red and on an HMI, if you program it that way, and it'll say, hey, go check this before things get bad. And then another one that people love in terms of sensors is when they need to replace one. So maybe they know that something is not right with a sensor, but just being able to find it. And so, we have the capability to remotely flash the lights on a sensor. So if you have a conveyor with 25 different sensors, you're like, okay, I definitely need to replace this one, or I need to clean it or whatever. You can flash the lights and then that way you know which one it is. So it's really just about like saving steps in the plant, right? So the fewer steps that the operators have to take, that always makes them happier, makes their job easier. So I think today, a lot of those like early in the digital journey, those like super simple, like seems obvious, those type of insights I think are the most valuable for the most customers. But increasingly, I think you're going to see on the business side of things, I could envision a day where you have all this information from both the true sensors as well as embedded sensors and drives, motors, et cetera, to be able to say, today I want to optimize my production for yield, or today I want to optimize my production for quality, and be able to configure the batch, the process, everything that all the configurations on all the devices to either, like I said, optimize. Today, we just want to crank out as much as we can, but another day, maybe we need to optimize for quality or for ESG metrics, emissions, et cetera. I think that'll all be possible someday. And so I think increasingly it's going to be the analytics used on the business side to really drive those decisions. And I think for sure there are those advanced customers that I talked about earlier who employ their own data scientists, like they are absolutely making use of that. But just in terms of that spectrum on the digital journey, there's so many customers today that are still like pen and paper, walking around the plant, that the really, really simple insights I think are going to be valuable to them for the near future, for sure.
A bit of a generalization, but that might also kind of relate to the size of the company too, because more likely a very small company is probably going to be still early in that journey of just knowing that, this seems to happen a lot. So let's just get some real simple analytics to help us save 10 minutes of checking, the idea of flashing a sensor to be able to identify which one is causing a problem instead of walking down and putting your hand in front of each one to check it. Just even that there is a savings of at least minutes or more.
Yeah. Absolutely.
And that adds up on the business case to be able to say, well, the downtime savings, although engineering is happy that things are up and running, the business case is also justified because you end up saving a lot of money with that increased speed of being able to track things down. So based on that answer, if somebody is kind of early in that journey and there could be some opportunities, are those very early stages then usually driven by the engineering's the operations teams? So they're kind of the pioneers or the champions of simple projects where they're just getting started. Is that usually kind of the best people to approach to say, hey, I think we've got an idea here on some data that we could use to start figuring out why this is happening all the time, or figure out how to make this part of our process a little bit better? Is it usually kind of that level of the engineering that people would go to start discussing that solution?
Yeah, I think so. I mean, it's always, when you're talking about bringing in a new product or a new method, procurement is going to be part of that conversation as well. But I do think that it is at that level of maintenance and operations management that kind of see the challenge more directly. I don't actually see as many like top down, like you guys must become fully digital. I mean, there's definitely some of that. I would agree. Like some of the bigger household names have a lot of initiatives around that, again, especially around things like sustainability and wanting to reduce carbon footprint, et cetera. And so they're really looking into those metrics. But yeah, I think it's more often if, the boots on the ground see some need and there is an opportunity with, deploying something like an IO-Link or, putting additional devices on Ethernet or another field bus. Like I think those individuals are going to be the ones to advocate for it. And then it's, always involving that conversation with purchasing around like, how do we get the return on investment for this, right? So is it completely cost neutral? Is it going to be something, if you're an OEM, can you upsell? So I think there's always going to be that conversation whenever there's progress, right? Whenever there's new technology, that comes into play. But I think it's increasingly becoming more standard because talked a little about the OEM, but then when you get to an end user, like the startup and the commissioning is so much easier when everything is just, again, in the Rockwell world, everything's on Ethernet IP. Everything comes back into your PLC. If it's on SupSafety, it comes into your safety task, your safety logic. Like it's just very easy. You can turn it on and it should hopefully all work. It's not, oh, I got to go check this wire and that wire and things are not connected. And now I've got to like do a home run back to the panel. Like it simplifies all of that greatly. So I think there's a lot of additional cost savings beyond like the actual data analytics. There's truly like time savings with the startup and commissioning that I think end users see, and then OEMs can help champion as well.
Yeah, and I guess really the only cost on the engineering side there is just making sure that people have the understanding or the training required to, if it's a new protocol that people aren't familiar with, to just be able to provide them with that understanding of it, rather than, like you said, just cables going all over the place. Might be more familiar to somebody whose background is in hardware and hardwiring, but so much opportunity to be able to be gained by making things more efficient.
We had that conversation a little bit with, there's a product that we released recently that's at single pair Ethernet based. So it's called Ethernet IP in cabinet. So it's a ribbon cable in the cabinet. And,
yes,
the question is like, yeah, but these guys are used to just going out there and sticking a probe on there, sticking a meter on there and seeing it. It's like, now it's all in Ethernet. So there is that little bit of like, you're used to just physically walking up to the device and checking something as opposed to like logging in and looking at it on the PLC. And so that's a little bit of a learning curve. But then back to our earlier conversation, I think a lot of the newer graduates that are coming out are more comfortable, like sitting there on their laptop and plugging in and being able to troubleshoot that way. I think we're really hopeful that it's going to be a net positive. Customers are going to see a benefit with all these things. But yeah, anytime there's new technology, there's a little bit of a learning curve. My mom's still learning how to text, so.
Well, I keep thinking, I'm probably still the generation where I understand technology pretty well, but I know there's going to be a time technology is going to keep advancing. But I did see that recent announcement about the in-cabinet Ethernet IP, and the first thing I thought was just, that looks fantastic. It did look interesting. I spent a long time looking at that thinking, I wonder how that works, and it'd be very interesting to see that, but it looks very exciting. Every time something is a commonly understood principle that's used in a new, interesting way is always really exciting to me.
We're excited. We hope people are excited too.
Do you have any specific examples, or perhaps maybe without naming companies? I realize sometimes you can't name really specific examples, but some of those cases where there was a condition monitoring solution that used some data from sensors to be able to benefit either the engineering side or the business side, or maybe ideally benefited both of them. That would be best case scenario.
I mean, I think as we just talked about, I think it always benefits both, right? Because operations reduces the time that they have to troubleshoot, the amount of times they have to be walking back and forth, and then it reduces downtime, so there's savings. Yeah, I mean, we talked. I think there's multiple customers that have had this scenario with our GuardLink protocol, but we have one on our website. There's a case study that is public that you can look up. And that's around a food packaging machine that had a lot of doors. And it was that exact situation of like, hey, which door is open, which door is misaligned, being able to save downtime with that. And that's multiple customers have really benefited from that feature on GuardLink. The other one that I always think of, because there was like a pretty substantial cost savings, and this is in tire and rubber. So it's a tire manufacturer that has, after the curing process, like while the tire is still sticky, it's going on a conveyor, going through the cooling area. And there's a photoelectric to time, the spacing between the tires as they got on there. And of course, anybody who's been in a tire plant, it's super, super dirty environment, and the lens would eventually build up, get dirty, wouldn't sense as well, and tires would stick together. And then if they cured, stuck together, those are two tires that you now can't sell. So we had a customer that used, looking at the margin on that sensor, so you can detect when the margin is below a certain threshold. You can configure that threshold. You can even configure that threshold to work with your CMMS, so it sends an alert, creates a work order, and have somebody go out, again, hit it with some compressed air, wipe it off, clean the sensor, and prevent both, the loss of the product as well as the loss of downtime. And this particular customer, I mean, their savings was, I think, approaching $500,000 a year just from that, because they weren't chucking out tires that are very expensive, and every two that stuck together, you didn't just lose one, you'd lose two. So I always like that example, because I think it's very simple, but it's like very concrete to people. Like as soon as you explain that, they're like, yeah, I can absolutely see why that's very, very beneficial. And had nothing to do with the core function of the sensor itself. It was just saying, hey, this sensor is getting dirty and you might want to go check it out.
It always seems like some of the biggest savings come from some of the simplest cases, and not always some huge complicated revelation of your data. Yeah. But it always makes me think back to like that learning in schools, and wondering how these kind of systems can be implemented in schools, and these big learning systems to be able to analyze like where air leakages might be happening, or multiple robot setups, and being able to get people working with this kind of software while they're still in that high school or college journey, rather than having to wait until the workforce to be able to experience analytics.
Yeah, I think for sure, like, I mean, my education was so theoretical. Like, I think there's so much value in having students understand the actual challenges in production. What does it look like? I mean, I just remember I did all these complicated calculus problems that would, talk about a process happening in a plant. Like I said, I was a chemical engineer, so I was running a fake oil and gas plant and cracking hydrocarbons and doing all that and figuring out what to do with my wastewater, but it was all completely theoretical. So I think for sure the more that students can kind of understand what are the real world problems, not just like what's the formula that you have to memorize and the math that you have to do, and how we can apply that. Like, I think that's extremely beneficial, and any university programs that incorporate that, I always think produce some of the best engineers for sure.
Yeah, and of course that's not to say that learning the theory is not important, but being able to get hands-on with something exciting, to learn, oh, this is why this is making such a big difference in the world. Right. Always seems like that influences or cements the learning so much better when you take the theory and then you move to application while you're still in that school environment. Well, Kate, we're reaching kind of the end of our time here, but I always like at the very end just a couple of fun questions to fill the remainder of the time. So I'm curious, what was your very first automation or engineering or robotics project in school, out of school, before school? What was that? And was it a real world project, or was it just kind of fun or for a hobby?
So I talked about my very first internship was at that plastics plant. But I think I would say my first like real engineering project that I did was actually the following summer. I worked on scale up production of a novel biotherapeutic. So, like I said, I was really interested in biomedical engineering at the time as well. And so I worked for a startup biotech company that was progressing through the clinical phase process with the FDA. And so each time you would scale up, you'd need to go from like bench scale to lab scale to pilot lab to full production, right, through the different levels, depending on how much product they were making. So I think they were going from like their phase 1 to their phase 2 study. So they were scaling up from kind of a pilot lab to more of a full production at a contract manufacturer. And so I worked on sizing one of the vessels that was going to be used in that next phase. And so that was the first, I'd say, like real engineering work that I did. And that was actually, contributed to doing something in the real world. And that's always been, I think, the piece that's most exciting to me is working on, now I get to work on product development and see products from just the early idea. I was fortunate enough to work for a time on that Ethernet IP and cabinet project you just talked about. And so now when they've actually released it and it's real, and I remember working on it.
So
yeah,
cool.
I have one on my desk. But like we had ideas when we were designing of like, how do we make sure people don't put it in the wrong way? Like, oh, let's put a line on it so they know which one is the top, and like that sort of thing, and seeing it out in the real world and seeing customers try it and use it and like hold it in their hand. That's always been the most exciting thing for me. And yeah, now I have 2 kids and they're doing their own little engineering projects around the house. So I always try to support that.
100%. Yeah, I have 4 that are really interested in taking things apart, and I think that's great, but we do it with strict controls sometimes.
Safety first.
Yeah, safety first, usually. Now, Kate, if you could go back in time and tell yourself one more thing, whether that's in college or early career, what would be that piece of insight that you would give to yourself? And I guess by extension, then you're kind of through this interview giving this to other engineers who might be following that same journey.
Yeah, I mean, we touched on it a little, but I wish I had done a little bit more of that practical hands-on, or just that would be my advice, I guess, is to continue with that. I remember one of my friends had studied abroad at Cambridge, like our junior year. And so she came back in her senior year and we were doing problem sets together, and like I would get an answer and I would just write it down, like whatever it was. I would do my math and I would be like, all right, it's like 600 Kelvin. And she'd be like, how could it possibly be 600 Kelvin? Like you're going through this heat exchanger and then there's this pump, and that, like, because she kind of had at Cambridge, they taught them very like to think very practically and to interrogate like the answers they're getting. And whereas, I was just like, as I said earlier, I feel like I had a very theoretical education. So I was like, I'm just doing the math. And, that I think if you can do that when you're young and sort of get into that mode of interrogating the answers, thinking about it on a practical level, being able to do that back of the napkin math, right? Like, oh, well, you're starting, the fluid's only like 200 degrees. And so how could it possibly, like, that really serves you well in anything in engineering. I do so much back of the napkin math now in my job. That's the only kind of math I do. And so I think that is definitely something that I would have told myself to focus on that more, and definitely encourage with younger engineers today.
Yeah, similarly, I had somebody encourage me once, and I still continue trying to improve and work on this, but they called it the common sense test. Does it pass the common sense test before you start putting the answer down, or calculating, or figuring out that 10th decimal place? Does your answer even make sense before you move on to the next step? And it's always I always have to keep reminding myself of that, but it's a very good way of thinking about it. So as a final question, if you could go back in time and meet any historical person, whether that be engineer or otherwise, who would that be and why?
Yeah, that's an interesting one. I was looking for ideas for this because I feel like it's so open. And one that I saw that I really liked that I wouldn't have thought of, but now I'm like, that's the one, is Tolkien. Because the guy was just such a genius. And like, I just want to know like how he thought of it all. Like if that was a really interesting one, because he created whole worlds, whole languages, just like a whole, I just think it would be really interesting to be like, how did you come up with that? Like, what was your idea? And it's just become such a pervasive cultural phenomenon that I'm not sure he could have ever predicted. So I really liked that idea. I thought that would be a cool person to go back and meet.
Well, as one Tolkien fan to another, I say that's perfect. I never actually would have thought of that response, but that's so perfect.
Yeah, yeah. I just remember like I read Tolkien as like a kid too, and I remember like studying the maps and the languages, and it's just and I love that it can be something that you take throughout your life, right? Like I remember as a little kid enjoying it, and there's like different things you take from it as you get older too. And I just would be curious like how somebody came up with that. It's not something I would have like there's no way. That's that level of genius is not accessible to me.
Well, so many brilliant minds that devote themselves to so many different things. It's a great place here. Well, Kate, thank you so much for joining us today. I really appreciate your experience, the time that you've given to us today. It's just been a real learning process for me. I love learning new things about automation and safety and sensing, and you've just provided so much insight. Just thank you so much for the time that you've contributed to us today.
Yeah, absolutely. Thank you so much for having me.
Once again, our sincerest thanks to Rockwell Automation and to Kate Sokolnicki for sharing her time and her experience with us today. And thank you to our audience for joining us today for this keynote. We hope that you will visit the virtual vendor booths and watch the other keynotes and live session events, all of which will still be available on demand after today, so that you can share the experience with anyone who may have been unable to join us live. Remember, the more sessions that you register for today, the better your chances of winning one of our session giveaways or becoming the lucky winner of our grand prize, which, for the first time ever, you'll have the chance to choose your own prize from our list of options. Thank you for joining us for this Control Automation Day 2025 presentation, and we look forward to seeing you again very soon. And once again, our thanks to all who attended this Control Automation Day 2025. We do have one final special announcement of our last two giveaway winners, as well as this year's grand prize winner. So for the giveaways, congratulations to Callie R. and to Jason Leverett. And for the grand prize, this year's winner is Eric Richardson. We'll be in touch with all of our winners after the event to make sure that we have all the information we need to complete the giveaways. And once again, thank you so much for attending, and we look forward to seeing you all again at our next Control.com special event. Have a great day.